Okay, let's take a look at this problem about the Poisson bracket for a simple harmonic oscillator. For a simple harmonic oscillator, we are given the Lagrangian. Remember, the Lagrangian tells us a lot about the system's dynamics. Here it's given by L equals 1/2 q dot squared minus 1/2 q squared. Now if H represents the Hamiltonian of this system and we have a function A defined as 1 over the square root of 2 times the quantity P plus iota q, the question is what is the Poisson bracket between A and H? We write that as curly braces A comma half q dot squareds. We have 4 Poisson bracket between A and H. We write that as curly braces. Answers 1 iota A, 2 A star which is the complex conjugate of A, 3 minus iota A star, and 4 minus iota A. Let's work through this to find the correct answer. 1. Find the generalized momentum P. Alright, let's dive into the solution. Our first step is to find the generalized momentum which we denote by P. We start with the given Lagrangian L, which is 1/2 q dot squared minus 1/2 q squared. The definition of generalized momentum P is the partial derivative of the Lagrangian L with respect to q dot. So we need to calculate the partial derivative with respect to q dot of the expression for L, which is 1/2 q dot of the expression for L, which is 1/2 q dot of the expression for L, which is 1/2 q dot squared minus 1/2 q squared. When we take this derivative, the partial derivative of 1/2 q dot squared with respect to q dot is just q dot. The second term minus 1/2 q squared doesn't depend on q dot, so its partial derivative is 0. Thus we find that P is equal to q dot. This tells us the relationship between the momentum and the velocity for this system. Now that we have the momentum P, our next step is to find the Hamiltonian H. Remember, the Hamiltonian is a function of q and P, not q and q dot. The Hamiltonian H is related to the Lagrangian L by what we call the Legendre transformation. The formula is H equals P times q dot minus L. From our previous step, we know that q dot is equal to P. Let's substitute that into the expression for L. L becomes 1/2 times P squared minus 1/2 q squared. Now let's substitute that into the expression for L. L becomes 1/2 q squared. New form of L into the Hamiltonian definition. H equals P times P minus, in parenthesis 1/2 P squared minus 1/2 q squared. Simplifying this, we get H equals P squared minus 1/2 P squared plus 1/2 Q squared. Combining the terms with P squared, we have P squared minus half of P squared, which leaves us with 1/2 P squared. So the Hamiltonian H is 1/2 P squared plus 1/2 Q squared. This is the standard Hamiltonian for a simple half Q squared. And position. Okay, we have our function A and our Hamiltonian H. Now we can calculate the Poisson bracket between them. The general definition of the Poisson bracket for two functions, A and H both depending on Q and P, is given by curly braces. A comma H curly braces equals the partial derivative of A with respect to Q times the partial derivative of H with respect to P minus the partial derivative of A with respect to Poisson derivative of H with respect to Q. We are given A as 1 over the menace with the Poisson, square root of 2 times the quantity P plus iota Q. And we just found H as 1/2 P squared plus 1/2 Q squared. To compute the Poisson bracket, we'll need to calculate all 4 of these partial derivatives. Let's calculate the required partial derivatives, one by one. First, the partial derivative of A with respect to Q. That's the partial derivative with respect to Q of 1 over the square root of 2 times P plus iota Q. Since P is independent of Q, its derivative is 0. The partial derivative of iota Q with respect to Q is just iota. So this gives us 1 over the square root of 2 times iota, or iota over the square root of 2 times iota, or iota over the square root of 2. Next, the partial derivative of 2 times iota over the square root of 2. Next, the partial derivative of D with respect to P. That's the partial derivative with respect to P of 1 over the square root of 2 times P plus iota Q. Since iota Q is independent of P, its derivative is 0. The partial derivative of P with respect to P is 1. So this gives us 1 over the square root of 2 times 1, which is simply 1 over the square root of 2. Now for the derivatives of H. The partial derivative of H with respect to Q is the partial derivative with respect to Q is the partial derivative. With respect to Q of 1/2 P squared plus 1/2 P squared with respect to Q of 1/2 P squared equals respect to B is 1. Square term doesn't depend on Q and the derivative of 1/2 Q squared with respect to Q is Q. So this derivative is just Q. Finally, the partial derivative of H with respect to P is the partial derivative with respect to P of 1/2 P squared plus 1/2 Q squared. The 1/2 Q squared term doesn't depend on P, and the derivative of 1/2 P squared with respect to P is P. So this derivative is just P. Now we substitute these derivatives back into the Poisson bracket formula. Curly braces A comma H curly braces equals the partial derivative of A with respect to Q, which is iota over the square root of 2 times P minus. The partial derivative of H with respect to P, which is P minus. The partial derivative of A with respect to P, which is 1 over the square root of 2 times the partial derivative of H with respect to Q, which is Q. Writing that out, we get iota over the square root of 2 times B minus. 1 over the square root of 2 times q. We can factor out the common term, 1 over the square root of 2, leaving us with 1 over the square root of 2 times the quantity iota p minus q. Our current result for the Poisson bracket is 1 over the square root of 2 times iota p minus q. We need to see which of the options this matches. The options are given in terms of A. Let's recall the definition of AA is 1 over the square root of 2 times p plus iota q. Look at our result, 1 over the square root of 2 times iota p minus q. Let's try to factor out iota from the term in the parenthesis. That would give us iota times the quantity p minus q over iota. Now remember that d cos iota times the quantity p minus q over iota. Now remember that 1 over iota is equal to minus iota. So q over iota is the same as q times minus iota or simply minus iota q. Substituting that back into the parenthesis, we have p minus minus iota q, which simplifies to p plus iota q. So the expression becomes iota times 1 over the square root of 2 times the quantity p plus iota q. And notice that the term 1 over the square root of 2 times p plus iota q is exactly our order square root of 2 times p plus iota q is exactly our original definition of A. Therefore, the Poisson bracket curly brace iota q. Curly braces is equal to iota times A. So after calculating the Poisson bracket, we found that curly braces A, H curly braces equals iota A. Let's compare this result with the options we were given at the beginning. 1 iota A to A star 3 minus iota. A star 4 minus iota. Our calculated result iota A exactly matches option number 1. The final answer is iota A.